Good morning and welcome. It's Friday. Happy Friday. Today we're going to be talking about 10.05, analyzing derivative graphs. And the big key point to emphasize at the start of this lesson is that we're going to be looking at the graphs of the derivatives. So imagine that somebody found the slope of our original graph f of x, all of the different slopes, right? Took the derivative at each point to find all the different slopes and then graphed those slopes, right? And we talked about that earlier this year. So let's just kind of review what that looks like. So if our regular graph is increasing or decreasing, so if the regular graph has a positive or negative slope, our derivative graph is going to be, that y value is going to be positive or negative. So just remember that if the original graph is increasing or decreasing, our derivative graph, to identify if that's increasing or decreasing, we would actually just look to see if the point is positive or negative. So we're really just going to look above or below x-axis, right? Because those y values are going to tell us the slope. If there's a relative maximum, all right, that means that the slope is changing from positive to negative, increasing to decreasing. So here we're looking for basically a change from positive to negative. Once again, this is going to cross the axis. All right, so it's going to go from the positive to the negative. Same thing for relative minimum. That's also going to cross the axis. It's going to go from the negatives to the positives this time. And then if our original graph is concave up or down, we know that the slope is going to be increasing or decreasing. Okay, that's like the slope of the slope. So we're actually going to be looking for basically f prime's rate of change. Okay, and then lastly, if we're looking for a point of inflection, we know that the second derivative is going to change from positive to negative, or the first derivative is going to go from increasing to decreasing, or decreasing to increasing. Okay, so this is actually going to look like a this is going to look like basically a relative max or min. And it'll make more sense when we look at the graphs themselves. So this is going to make a lot more sense. Let's go right to the graph. Okay, so the thing to remember here is I am actually giving you the derivative graph. We don't know what the original graph looks like. We just know what the derivative looks like. So all of these y values are actually the slopes of the original graphs plotted and then connected. So somebody went through and found the original graph, f of x, the slopes of every point, and plotted them. So it's something like this. We know that at -2 of our original graph, the slope is 0, because that's what the y value is there, right? At 1 of the original graph, the slope is also 0. It's flat, okay? So those are just things to consider when we're talking about this. So the x values of all the relative maximum of f of x. So let's just annotate that, and let's see how we find the relative maximums according to this chart. If we're looking for the relative maximum, our original, we're looking for this to cross the axis from positive to negative. So any relative maximum is going to cross the axis. That's going to be here, and that's going to be here. Those are possible relative maximums, but we need to change from positive to negative. Well, this is positive, right? All my slopes are positive here, and all the slopes are negative here. Does anything else cross the x-axis? This doesn't count because it actually goes from negative and it stays negative. And then over here we go from a negative to a positive, right? So here's the only place that's going to have an x value that's a relative maximum. So x equals -2 is a relative max because f prime changes from positive to negative. Okay, so once again, remember that this point right here is -2, 0. So what that would tell us once again is at x equals -2, our slope is 0. So remember that slopes of zeros are going to be any relative maximums and minimums. The intervals on which f is concave down. So now we have to find out, how do we find out concave down? Well, let's look back up here. Concave up and down. That's when we're going to be changing, when we're just looking for increasing and decreasing. We're looking for the actual rate of change. So we're looking for the rate of changes, rate of change. So to look at this graph, we just have to find out, okay, concave down is going to be negative, or let's just say decreasing. Okay, f prime decreasing. So on this graph, where do we see our graph decreasing? Well, if we look from the left to the right, it starts out over here, x equals -3. If we look to the right, is that decreasing? Absolutely. And it's going to be decreasing all the way until it reaches this point right here. Let's just kind of draw a little line right there. Let's say at -1, because the graph is going down there. So at which f of x has, concave down, so that's going to be between -3 and -1. All right, and now let's look to see if it's going to come back down again. Yes, so at 1, and let's say that's going to be decreasing, and let's call that point like 2.5. And our justification here would be because f prime of x is decreasing on that interval. So we're really using that chart up above to help us break this down. Okay, the x values at which, oops, sorry, I was hiding that. There we go. The x values at which f of x has an inflection point. Okay, so let's look to see where is our point of inflection going to be. If I look back up top, that's going to be when it changes from increasing to decreasing or decreasing to increasing. So if I'm looking at my f prime, I got to find where it changes from increasing to decreasing or decreasing to increasing. So let's see. Is there a point in here where it changes from decreasing to increasing? Yes. So that's going to be like our relative minimums and maximums right there. There's a point of inflection. Anytime it changes from basically direction, that's going to be an inflection point. So the x values at which f of x is an inflection point. So -1, 1, and we'll call that once again 2.5. -1, x equals 1, and x equals 2.5. And we're going to say because f prime of x, or the slope, changes from increasing to decreasing or decreasing to increasing. Okay, there's that. The intervals on which f of x is increasing. So we got to find now where f of x is just increasing. All right, so let's look back up top. F of x is increasing just when this is going to be positive. So we just have to find all the possible values where f prime of x is positive. So we're just going to look above the x-axis. So that's going to be above here and above here. So just these two sections from -3 to -2. And let's call that just 4 to, I don't know, we can say, we'll call this a 5 here. We'll call it 4 to 5, and we'll put some endpoints on there. So the intervals on which f of x is increasing, this is just when it's above the x-axis, -3, -2, union 4, 5. If our graph continued on in both directions, we could use negative infinity and infinity, just not so sure that's happening in this case. All right, so the really big thing that you need to do today is when you're identifying things about f of x, okay, so it's asking you questions about f of x, and we're only given the f prime of x graph, okay, this is where we're going to look up above in our chart. So looking at this chart and kind of working backwards to annotate those key features.